All right, Mr. Dodd, working through rules of derivatives again. This one we're going to talk about the chain rule. I've hinted at this before, but you have to use the chain rule when there's a function inside of a function. Everything I've done up to this point, the derivative of the inside function has been 1, and when you multiply by 1, it's fine. It doesn't actually change the answer, so that's why I was able to kind of cheat my way around that. But with this, okay, basically, that should say the chain rule. Basically, the chain rule takes something that has multiple layers and then peels back the layers one at a time. So you take the derivative of the outside function without touching any of the stuff on the inside, f prime without touching g and h. And then you multiply that by g prime, once the f layer has been peeled away, g prime, and then h is on the inside. And then once the g layer is peeled away, you multiply that by the derivative of h. So I think the best way of looking at this is a couple examples. So this is how a chain rule problem works. Notice I have an x to the fourth on the inside, and then I have, or something to the fourth, and then I have x cubed plus 5x. That is the way that we work through these chain rule problems. So this one had 3 layers. This guy only has 2 layers. So the 2 layers are the something to the 4th power, and then the x cubed plus 5x. Okay. So f prime of x in this case, the outermost layer is this something to the 4th power. Okay. And the way we deal with something to the 4th power is just to use the power rule. I'm going to multiply my exponent out front. I'm not going to change the inside at all. And then I'm going to subtract 1 from the exponent. Okay, so that is how you would deal with the outside layer, the 4th power. Then, once that layer is peeled away, I kind of work my way in. There's only 2 layers here, so I'm dealing with x cubed plus 5x. Again, I'm going to multiply and then use the power rule. That would give me, multiply my 3 out in front, 3x squared plus 5. And that would be my derivative of this first f of x, part A. Okay. Again, I didn't leave myself a ton of room, so I'm going to work down here. Again, I have an f of x where I have an outside function, the square root, which we can rewrite as x squared minus 4x to the 1/2. Okay, I'm going to scooch this up a little bit so we can, so I can use the bottom of my page here. F of x equals this guy right here. Again, I have an outside exponent and then inside values of x as well. So f prime of x equals the 1/2 is going to come out in front. X squared minus 4x, I don't touch that at all. Subtract 1/2, or subtract 1 to give myself negative 1/2. And then with the chain rule, you just multiply, peel your layers off, and then multiply. My next layer, I'm taking care of that 1/2 exponent. So the derivative of 2, or x squared is 2x. The derivative of minus 4x is minus 4. And then those just get multiplied together. So that is my derivative for that second function. Okay. And then this one's going to take a little bit more space, so I'm going to use a little bit more space. First off, I'm going to rewrite this. So I have sine squared of 5x minus 3. Now, we haven't dealt with the trig derivatives yet. The derivative of sine is cosine, and I'll talk about that more in R6. But for now, I'm just going to ask you to believe me. But this is the best way I could think about writing one that had 3 layers, just like this guy does in the original question that I asked. So I could rewrite this as f of x equals sine of 5x minus 3 squared. And the reason I know that it's a 3-layered one is that I have this squared on the outside, and then I have the sine. So I have a square, I have a sine, and then I have a 5x minus 3 on the very inside. So f prime of x equals, I work outside to inside, so my exponent here is a 2. 2 times sine of 5x minus 3 to the first power, which I don't need to mark, but I will just for clarity's sake because 2 minus 1 is 1, times, now that I've taken care of that square, what's the next layer that I need to deal with? Well, it's the sine. I told you earlier the derivative of sine is cosine of, don't touch the inside, 5x minus 3. And then once I've peeled away this square, and I've peeled away this sine, all that's left is 5x minus 3. The derivative of 5x minus 3 is 5. So I have these three things multiplied together, and that is going to be my, my function. This can simplify slightly. Again, I'm not super worried about this usually because I want to use the derivative rules, but on this one I have a 5 and I have a 2, which makes it 10. So it's going to be 10 sine 5x minus 3 times the cosine of 5x minus 3. If this would have been the function that I was taking the derivative of, notice that I would have had to use a product rule because I have two things multiplied together, so I'd need to use a product rule there. But that is the chain rule. Just peel the layers back and multiply by the derivatives as you go.